Hello, my name is Beth Dixon, and this is a video series based on Vicki Borlaug's PowerPoint presentation on correlation, and this is an introduction. I wish to thank Mrs. Borlaug for allowing me to use her PowerPoint to make this set of videos. We have a correlation coefficient defined as the variable r, and it measures the degree to which two variables relationship is associated with a specific curve such as a line. For our purposes, we're only looking at linear relationships. So R is a value between 1 and -1 that tells us to the degree that two variables are related to each other as a line. Let's review in statistics that for the mean, x bar is used to estimate the mean. X bar, the sample mean, is used to estimate mu, the population mean. And in standard deviation, S, the sample standard deviation, is used to estimate sigma, the population standard deviation. And in proportions, p hat is used to estimate p, the proportion. And as we're talking for now, r is used to estimate rho. And this is not a p, this is the Greek letter rho. The Greek letter rho. It looks sort of like a p, but it's the Greek letter rho. Notice that for population, we're dealing with the Greek letters, and over here, we're dealing with the normal letters, except maybe in proportion. Well, other than that. So, we're studying in this video and in this PowerPoint, R is our sample correlation coefficient, and rho is our population correlation coefficient. And we're going to be looking at samples, and therefore we will be talking about R, which is the correlation coefficient for that sample. What is the correlation coefficient? I gave you a kind of a rough definition earlier. Let's look at some more detail about the correlation coefficient. Now, some teachers actually have you use the formula. And that's what the formula looks like. And it's called the correlation coefficient. It is long, it is ugly, and it is difficult to use, especially as you get more pairs of numbers. I am so glad that the calculator can do this for you. We can get this R from our TI-83 or 84 calculators. Notice that the calculator screen will give us R and R squared, and we will actually talk about both of these numbers in our PowerPoints and our videos that I will have available on these, and we'll talk about what each of those numbers describe for us. Now, why is the sign of the correlation coefficient important? Well, we can get a positive correlation coefficient, we can get a negative correlation coefficient, or we can have 0 as the correlation coefficient. So we have three possibilities, and that will be important to us. If the variables have a linear relationship, what does the sign of the correlation coefficient tell us? Well, it tells us the slope, because slope can also be positive, negative, or 0. So if the population correlation coefficient rho is positive, then the slope of the linear relationship is positive. If the correlation coefficient is negative, then the slope is negative. And if the correlation coefficient is 0, the slope is 0. Remember that the sample correlation coefficient is R, and that the population correlation coefficient is rho. R is used to estimate rho. First, let's discuss what it means for a data to have a linear relationship. Look at both sets of dots and relationships. These are ordered pairs, an X grouped with a Y, a set of numbers where we're associating one number with another number, an input with an output. For a data sets to have, well, we're going to talk about positive and negative slope. The first one here has a positive slope. The trend is upward. As we look from left to right, the trend is upward. On the second one, we have a negative slope. The trend is downward as we look from left to right. For a data set to have a linear relationship, the general trend of the data must be linear and the slope must be non-zero. We consider something with a slope of 0 to be a line, but for data sets to have a linear relationship, we do not want them to have a 0 slope. So these two things must be true. The general trend of the data must be linear and the slope must be non-zero, either positive or negative. Does this set have a linear relationship? For the data set to have a linear relationship, the general trend of the data must be linear and the slope must be non-zero. The slope is not non-zero. No linear relationship because this slope is 0. Does this data have a linear relationship? Well, it has a relationship. There's clearly a pattern. But the general trend of the data must be linear. This data is not linear. Therefore, there is not a linear relationship. No linear relationship exists because the trend is non-linear. It looks like a parabola. Okay, we're going to pause here because this is a good place to stop. If I can't cut that out as smoothly as I like, I apologize for that. But we are going to pause here to keep these videos short. In the next video, I'm going to talk about positive and negative slope and how to determine that by looking at the graph. And we will pick up here in the next video. Thank you.